Welcome back. In this tutorial, we're going to look at the carbonyl containing compounds. We're talking about the aldehydes and ketones. In this tutorial, we're just introducing this homologous series. We're going to look at other things later. We're going to look at how we name these compounds in detail later. We're going to look at the chemical reactions, and also we're going to look at the physical properties of these compounds later. In this lesson, we're just trying to understand what are aldehydes, what are ketones, and just name a few examples of these compounds. Right, aldehydes and ketones contain the carbonyl functional group, where the carbon atom is bonded to an oxygen atom by a double bond. And then this carbon may be bonded to a hydrogen atom or a carbon chain. So we're going to have our R here representing a carbon chain or hydrogen atom, and another R that could be representing a hydrogen atom or a carbon chain. We'll discuss more about this as we try to understand the difference between aldehydes and ketones. We said we have aldehydes and also we have ketones. Let's start by discussing aldehydes. In the aldehydes, this carbonyl group is at the end of the carbon chain. A simple example of an aldehyde is methanol, and the common name for methanol is formaldehyde. In methanol, we have our carbonyl group, and then the carbon is also bonded to a hydrogen and also a hydrogen. Let me give another example. Let's use ethanol with a common name of acetaldehyde. Ethanol, we have two carbons. So the first carbon is the one with the carbonyl group, and then we have this carbon bonded to the hydrogen and also to an alkyl group, which is the carbon chain. You see that? So we're saying that for aldehydes, this carbonyl group is bonded at the end of the carbon chain. Right, we can have another example, which is like propanol. Right, we can have the carbon there, and then we have another carbon there, and then we have the third carbon where we have this carbonyl group being at the end of the carbon chain. These are examples of aldehydes. And then when naming aldehydes, we use the suffix "-al", like ethanol, methanol, propanol, like that. And then the general formula is CN and then H2NO, like that. That's the general formula for aldehydes. And then the uses. Aldehydes are used in perfumes and flavorants. They are also used in resins. They are also used in the production of plasticizers. Formaldehyde is used as a preservative for biological specimen. Okay, these are some of the uses of aldehydes. Remember, we say that we're going to discuss these compounds in detail in the lessons that are going to follow. Let's go to ketones. Right, in ketones, this carbonyl group is in the middle of what? Of the carbon chain. A good example would be propanol. We have the carbonyl group, and then we have the CH3 there, and then we have the CH3 there. This is an example of ketone. The carbonyl group is in the middle of the chain. The aldehydes, like I said, you can have at least one hydrogen atom, meaning that you can have a hydrogen atom there and a hydrogen atom there. Also, you can have one hydrogen atom, and then where the other one is what? It's a carbon chain. But for ketones, you must have a carbon chain there and a carbon chain there and a carbonyl group. The suffix that we use in the naming of ketones is "-on", like propanone, butanone, pentanone, like that. And then the general formula is the same as that of aldehydes, CnH2NO, like that. The common name for propanone is acetone. That's the common name for propanone, right? Ketones are used mainly as solvents. They are used in the production of polymers, and they are used in the production of pharmaceuticals. Please remember that. So we mainly discussed here what these carbonyl containing compounds are, and then we looked at aldehydes and ketones. We tried to identify the difference or the differences between aldehydes and ketones, and then we're going to discuss more about these compounds in the following tutorials.